Okay, so we're going to end the cardiorespiratory system unit by talking about the final respiratory challenge. So again, here are our outcomes that we've had for the last 3 lectures, now this one. All right, and so our big challenge is we can increase ventilation by 20 or more times, which means that our work of breathing has increased. And so we need to find a way to minimize that work of breathing. Okay, so we don't often think about this, but the more we exercise, the more we have to breathe. Like, it makes sense, but that breathing comes at a cost. Okay, and when you're at max exercise, it's possible that the respiratory muscles might account for 15% of your VO2. Okay, that's a lot. And so the problem with that is if it's going to your lungs, it's not going to your muscles. So we've got this figure here, and if you look, and this isn't even maximum exercise, right? We're only going up to 70 liters a minute. So this is relatively low intensity exercise, maybe getting up to 50 or 60% of max. So notice just the width of the red bar. Okay, that red bar represents how much blood flow is going to your lungs, or to your respiratory muscles, so that breathing can occur. And notice that it gets bigger. Now, it shouldn't be a surprise, but it's something that we don't always take into account. Okay, and so this can be an issue with maximal exercise. And so really another way to think about it is, if we increase the work of breathing, that means, or if we decrease the work of breathing, we're going to have more blood flow go to our legs. If we increase the work of breathing, that means there's less blood going to our legs. And we can see that from this figure here, right? So on the left side, we've got relatively low amounts of work of breathing, and so we've got a lot more blood flow going to our legs. But on this red line, work of breathing is above control, so it's more than normal. And so now we're decreasing the amount of blood that's going to our legs. So there's a couple ways that we can kind of maximize or minimize the cost of breathing. Okay, so if you look here, we've got like a spirograph here. And so we've got tidal volume, which is this little line here. And sorry about that. And then this is big breath in, big breath out, that sort of thing. Now notice during light exercise, we've got tidal volume doesn't increase a whole lot, all right? But then as we go from moderate exercise, notice that moderate to heavy exercise, notice that the frequency remains pretty consistent, okay? But what's changing is the actual size of the breaths, or the tidal breaths, right? So we've got 4 breaths in here, we've got 4 breaths in here, almost 4 breaths. And then so we've gone from 50 to 85, and this is all primarily done by just increasing the size of every breath. All right, but then when we go to max exercise, we're actually breathing, our frequency increases, right? Tidal volume is increasing a tiny bit, as you notice that this line is a little bit lower, okay? But we don't fill our lungs up anymore, we just breathe down a little bit. So we're taking bigger breaths out, okay? And what we're trying to do is we're trying to maximize how much air we can get into our lungs. All right, and we've got this figure here that helps explain this. So on the x-axis, we've got pressure, and on the y-axis, we've got volume. Okay, now there's a reason that we breathe at the lung volume that we breathe. I've had you guys do this in class before. So just to kind of refresh your memory here, take a big breath of air in. Now start to breathe normally while breathing with your lungs almost completely full. How does that feel? Okay, the answer is it doesn't feel great. Now, if you breathe a lot of air out and then try and breathe at a very low lung volume, how does that feel? Again, it doesn't feel great. And the reason is because of this relationship between pressure and volume. We're trying to stay on this sweet spot right here. Okay, sorry, that's not supposed to curve, but basically where this line is essentially pretty parallel. I guess it's pretty steep. That's the word I'm looking for. It's not parallel, but it's pretty steep. And what that's telling us is that for a change in pressure, we're actually having a big increase in volume. But once we get, let me erase this here. Once we get to kind of this inflection point right in here and right up here, okay, we have to generate a lot of pressure to have a change in volume. And so we want to stay on kind of the sweet spot. We want to stay where we get the most bang for our buck. And so that's why it's important that we take bigger breaths. But eventually we get to a point where we're not going to get very much out of it by taking bigger breaths, because we get onto these flat part of the curves, which means we have to generate a lot of pressure, but we're not getting any real change in volume. Okay, and so once we hit that point, then our frequency really starts to go up. Okay, and so we can see this. This is called a flow volume loop, and this is a really unique graph here. So there's no time component. Volume is on the x-axis, airflow is on the y-axis. What's really strange about this is that as you take a big breath of air in, so this is you inspiring, so it goes kind of wonky, different than what you would expect. Okay, so this is a big breath of air in here, and then you blast it out. And so that's how this is done. Okay, and so notice that as we increase, basically you think about it, increase intensity, that these loops, these tidal loops, get bigger and bigger and bigger. And really what we're trying to do is we're trying to take advantage of where we can be on that sweet spot, where we can breathe with the least amount of cost. Okay, where we have to generate the smallest amount of pressure. Okay, and so this is why when we exercise, we first increase tidal volume until we get to a point where to increase tidal volume actually starts to cost more. And so then we'll increase our respiratory rate. If we increase our respiratory rate from the beginning, that means our diaphragm has to contract more often, and that's going to cost us energy at the beginning. And so we try and hold off on it, having that increased cost from the diaphragm contraction by causing bigger breaths to come in.